Hello everyone. In this video, I'm going to walk you through question number 8 of part 1 of RF Technology homework assignments. Q&A. The question asks for designing a step impedance filter. It's a low pass filter, and the pass band has 0.5 dB ego ripples. The cutoff frequency is 3.101 gigahertz, and the attenuation at the stop band is 20 dB at 4.65 gigahertz. The reference impedance is 50 ohm, and you are given the highest impedance, 125 ohm. The lowest impedance is 20 ohm. So you use these two impedance lines alternately to design a low pass filter. And the filter, according to the question here, ego ripple, it must be Shabbaters. You will not get in Butterworth filter. The specification is not given in this way. Only Shabbaters filter has this characteristic. So, in other words, you're going to design a low pass filter, and your first job is to design the order. You need to determine the order of the filter. The order of the filter, I'm going to switch off the presentation mode. So stop sharing. So you are now looking at my whiteboard. Now, first of all, I'm going to write down what we have got in the question. The ripples is 0.5 dB. The center frequency is 3.1 gigahertz. The stop band gain, or you can say the stop band attenuation, minus 20 dB, and the stop band frequency is 4.65 gigahertz, and the characteristic impedance is 50 ohm. The high impedance line has a characteristic impedance 125 ohm, and the low impedance line is given to be 20 ohm. So first of all, you need to use what you have to design, to find out the order of the filter. The order of the filter is going to be obtainable using this equation. 10 A divided by 10 minus 1, and then 10 R. R means the ripple, yeah. R minus 10. A and R should be given in dB, and A cosine Fs Fc. Fs is the stop bound frequency, 4.65 gigahertz, and F of C is the center, the cutoff, the corner frequency. So if you do it carefully, you will get, yeah, the first of all, yeah, I'm going to stop, put some value into the equation. AS, besides the AS. So minus 20, which is 20, and then 10 minus 1, and then 10, 0.5, A cosine 4.65 divided by B.101. Yeah, make it more accurate. So if you do it carefully, you will get the answer 412. Of course, the order of the filter has to be an integer. In this case, you cannot put 4 there because 4 is obviously less than 4.2. So you need 5. You need 5. You need the order of the filter has to be 5. So what you need is to use the characteristic equation. So with V not equal to 50 and V not H equal to 125 and V not L equal to 20. Then we can get, now the next thing is to find out the prototype value. T1, T2, T3, T4, 4, T5. So according to the prototype table, you are given 2065, 12293, 2.5419, and then 1.2293, and then 1.7068. Then the next thing that you are going to do is to use the formula. So you're going to calculate the length of the line corresponding to G1. So beta L1 is equal to, you use the formula. The formula is here, and then H. So 1.706A times 20 and VH 125. So you will get 0.6827, and in radian. And if you translate it in degree, this should give you 35 degrees. And similarly, and you can continue with the rest of the process. Beta L2. The next one should be capacitance. In this case, you use the low order. So it will be 1229D times this value 20 divided by 50. And if you do it carefully, you'll get 0.4917 radian. And this is equivalent to 28.2 degree. And similarly, you can do this for the first section. And then the first section is G3. The formula will be exactly the same as the first one. And it will be a high impedance line. And 2.541 times 50 divided by 125. And if you do it very carefully, you will get the 1.0168, and this is equivalent to 58 some degree. So G4, you don't need to really calculate it. So you just need to copy, yeah. G4, because G4 and G2 are the same. So you don't need to do too much calculation. So it will be the same. And 28 degree. And similarly, beta L5 will be the same as the first one. It cannot be otherwise. I don't need to even calculate it. So finally, the filter phototype will be like this. In the first section, it will be a high impedance line. The length will be 39 degree. And the second section will be a low impedance line. Low impedance line. And this is the first one is 1275 ohm, and the second one will be 20 ohm. The length here will be 28.2 ohm. And similarly, the length here will be much longer. Much longer. And according to my calculation here, the length here is 58 degree. And the impedance is 125 ohm. And here, the length here will be 28. So if the order is odd order, then the filter will be symmetrical. The final one, 39 degrees. This is your filter. And I can tell you the quality of this filter may not be good, but you will frequently encounter this filter topology in microwave circuit. The main reason is this is easy to design. Okay, if you have any question regarding this one, then just leave your question to the comment section of the video. And remember, this is the answer for QA. Yeah, I write down here. Question A. Yeah, the answer for question A. Okay. Thank you for your attention. Bye bye.